Hello friends, welcome to InfoStree channel. Today we are discussing some important question about organic chemistry which can use for a 12 PUC and degree and for a PG students. Let's see the question. Our question is explain the various application of ultraviolet spectroscopy. They ask the application of ultraviolet spectroscopy. Let's see the answer. Okay. Ultraviolet spectroscopy has numerous applications across a various fields, including quantitative analysis, qualitative analysis, structure elucidation, biological application, environmental application, and research and developments. Let's see one by one how it works. Okay. So here, quantitative analysis is used to determine the concentration of a substance in a solution, used to analyze the purity and concentration of pharmaceuticals. Qualitative analysis means used to identify compound based on their characteristic. Absorb spectra used to detect impurities in substances. To detect the impurity substances, we use the ultraviolet spectroscopy technique. Okay. And structure elucidation. Elucidation means to explain something clearly. It means this ultraviolet spectroscopy explains structures clearly. That is determination of molecule structure of compound, study of conjugation and resonance. And one more is biological application, study to protein and nucleic acid. This ultraviolet spectroscopy is used to detect a biomolecules such as a DNA, RNA and protein, and also for used in environmental applications to detection of pollutants, monitoring of water quality to detecting the presence of contaminants. To determine the purity of water, we use this technique. And last one is research and development, to study the chemical reactions, development of new materials with specific properties. UV spectroscopy is powerful analytic technique with a wide range of application across various fields. So not only these are there are also some more applications of this ultraviolet spectroscopy, but for the 5 marks questions this much is enough to write. It may also come for 2 marks also, you can write it this much. Okay. And now one more question is, let's deal with the one more question, that is describe any two method of a determination of a simplification of a complex NMR spectra. They asked the method of determination and simplification for the NMR spectra. Okay, first one, spin decoupling, selective decoupling principle. Let's see the spin decoupling principle. In complex spectra, peaks appear as multiplates due to coupling between neighboring protons. If a particular proton signal is irradiated with a second radio frequency, its coupling with a nearby proton disappears. How it simplifies? Removes a coupling interaction. A multiplate becomes a singlet. Helps identify which protons are coupled. Example, in ethanol, irradiating the CH2 protons removes their coupling with a OH or a CH3, making it easier to assign a peaks, which is helps to assign these peaks. So that is spin decoupling. And importance of this are useful in a structure elucidation and helps to determine coupling relationship. So second one is chemical shift reagent. We can write a chemical shift reagent for a determination and simplification of a complex NMR spectra. So the principle is paramagnetic lanthanide shift reagent. Example, ultraviolet interact with the molecules and shift the chemical shifts of a nearby proton without altering their coupling pattern. Without their altering a coupling pattern, we can do this. So how it simplifies? Protons that were overlapping move apart. Crowded region become separated, makes peak assignment easier. Example in complex or a crowded aromatic spectra, addition of a UV FOD3 shifts specific protons downfield, separating overlapping signals. Importance: useful for a complex organic molecules, helps resolve overlapping peaks, provide a stereochemical information. These are the two important questions for a PU and degree students, also for a PG also. It for use it may come for a 2 or a 5 marks question. So I hope you understood.